So this is a review real quick of yesterday. Yes? There were several people having trouble which one of these to put where in the division problem. Are you guys okay with that? Whatever I'm dividing by goes on the outside. Whatever I'm dividing into goes on the inside. Take the first term, divide it by the first term. I get x, write it up here above the term that it's like, and then I multiply. X times x is x squared, x times 2 is 2x. Then I subtract each term. Combine, that's a 0, that is a 3x. Bring down the next term. Start all over again. Divide the first term by the first term, and I get 3. I write it above the term that it's like, then I multiply. 3 times x is 3x, 3 times 2 is 6. Then I subtract each one of those, and in this case I get 0. Okay, so far? What about this problem? Do I do it any different because there's 4 terms here instead of 3 terms like there were in this problem? I don't do it any different, do I? I start first term on the inside divided by the first term on the outside. What is x cubed divided by x? X squared. I write it above the term that it's like. Then I multiply. What's x squared times x? X cubed. What is x squared times negative 1? Negative 1x squared. Then I subtract each term. That's what happens when I subtract this term. I'm adding because I'm subtracting a negative, so I'm adding. Okay? Is this 0? Is this always going to be 0?
Yes.
If you did it right, yes it will, won't it? Okay? What's this?
6x squared.
6x squared plus 3x minus 4. I'm just bringing down the rest. Okay? Now I start again. Divide the first term by the first term. 6x. I write it above the term that it's like. Now I multiply. 6x times x. 6x times negative 1. I subtract each term. Once again, if I subtract a negative 6, I'm adding it, aren't I? This is 0. Is this always going to be 0? Okay, what's this? 9x minus 4. Because I just brought down the next term. Now I start all over again. What's 9x divided by x? 9. Now I multiply. 9 times x. 9x. 9 times negative 1. Negative 9x. And I subtract. If I'm subtracting a negative, I'm adding, remember? 0, 5. How do I know when I'm done? Here it was easy because I got a 0, right? How do I know when I'm done? You can't drop anything else down, first of all. And 5 divided by x gives me an x in my denominator, and I definitely don't want that. Right? That's how I know that's part of my remainder. Plus 5 over x minus 1. Any questions about that?
I just always get lost.
Okay, well, you're in room 10, so you don't ever have to worry about getting lost again. No, you really are in room 10, I'm telling you. You don't even have to look on the map or anything. Three x to the 4th plus 5x squared plus 6x minus 10 divided by 3x squared minus 4. So we need to set this one up, right? What goes where?
3x squared minus 4 goes on the outside.
Okay. What goes on the inside? Be careful. I'm trying to trick you. What goes on the inside?
You need to put it in,
You need to add a 0.
3x
Where?
4
Uh-huh.
plus 5x. No, wait,
No,
plus
0
0x.
0x cubed
Plus 5x squared plus
5x squared plus 6x minus 10. Now what? Now we start the pattern, right? First term on the inside divided by the first term on the outside.
X squared.
Can we go slow here, please?
Yep.
It's like, and then go on to the next one. And I'm like, okay?
Well, remember, these are exactly the examples I did yesterday, too. So, 3x to the fourth divided by 3x squared. Well, 3 divided by 3 is going to be 1. X to the fourth divided by x squared,
X squared.
x squared. So I'm going to write it above the term that it's like. And then multiply. What's x squared times 3x squared? 3x to the fourth. What's x squared times negative 4?
X squared.
So negative 4x squared. Why didn't I write it right here?
Because that's cubed.
Yeah, it's a cubed. I need to write it under the term it's like. Just like I'm writing this above the term it's like, I need to write under the terms that they're like. And now, subtract. Minus a negative is plus. Okay. This is 0. This is 0. 9x squared.
Bring everything down to
Bring everything else down. Good. Now start again, right? 9x squared divided by 3x squared. Well, what's 9 divided by 3? 3. What's x squared divided by x squared? No, it's not x squared.
X.
X squared divided by x squared. Anything divided by itself is what? 1, right? Anything divided by itself is 1. So I just end up with 3. Not 3x. Guys, look. 9x squared divided by 3x squared. Anything divided by itself is just 1. That's gone. 9 divided by 3 simplifies to 3 over 1. So I just have 3. That's all I have left. Okay? Does that make sense? Above the term that it's like. Now what? Yes, ma'am.
I don't understand why we have to put like 0x.
We'll talk. This time it didn't matter. Sometimes it does. Okay? Some of the stuff I show you today is going to. Okay? Ma'am.
Why didn't you bring down the 0x cubed?
Because it's 0. I didn't need to bring this down because it's 0. Okay? What you got?
So it's okay to like skip the x term and go straight to it?
Uh-huh. Sure is. There's no x term here because we didn't have an x cubed term. This is a 0 term, right? In this particular example, this doesn't matter, but I got to put it in there just in case. Okay? So why didn't I put it over here? Why didn't I put an x term over here? This one's not as important. Okay? If you want to put in a 0x over here, that's fine, but it's not as important. This one always is important. Well, except for this time, when I'm showing you, of course. Okay? So we divided this by this, and we got 3. So now what do I do? Okay, so multiply. 3 times 3x squared. 9x squared. 3 times negative 4. Negative 12, where do I write it? Under the 10, right? Now what? Subtract. Subtracting a negative is adding. This is 0. This is 6x. And this is 2. Now what? That's my remainder, right? Now, people yesterday were getting confused because there's an x term here. It seems like we should still be able to divide. Except what are we dividing by? An x squared term. That's bigger, right? So I just have my remainder. Plus 6x plus 2 over 3x squared minus 4. And that is my answer right there. that make sense? Okay. So I told you yesterday that I would be teaching you another kind of division today. And somebody who's being a little bit of smart aleck said, what, so this one's going to be easier? Well, yes. Yes, it is. The problem with this one is that it doesn't always work. Alright? So I'm going to do some examples for you, and then you'll be able to see when it works and when it doesn't. Okay? I'm not going to figure that out for you. You're going to figure that out. Okay? So we're going to do this exact problem because we already know the answer. At this point, the answer is not the most important part. It's the process, right? So we're going to do this problem right here. So I'm going to set this problem up for you. Okay? First of all, our division sign looks like this. And there needs to be 2 rows of numbers here, in case you're wondering as you draw it. Okay? What am I dividing by? X plus 2. So what's going to go right here is we have to set this equal to 0 and solve it for x. I need to know just what x equals. In this problem, x equals -2. So guess what goes on the outside? -2. So are you ready for what's inside? 1, 5, 6. Did I just make up those numbers? What are these called? Coefficients. That's exactly right. Okay? So some people earlier said it kind of looks like a matrix. They're right, doesn't it? It kind of looks like a matrix, kind of, ish. Right? We're using the same kind of concept. We're just looking at the coefficients, aren't we? Okay. Now, sometimes I have a really hard time doing this slow because it goes so fast once you know how to do it. So I promise I will try to do it very slow for you. Okay? First thing I do, whatever number this is, I just bring it down and write it again.
Okay, I have one question for you.
Okay, hold on. What'd you say, Duke?
So you always bring it under?
Whatever it is, yes, I always bring it under. Yes, ma'am.
Okay, so if it said like x cubed, you'd still put 1, because it's only like 1x. Because this one says x squared.
If it says x squared, I've got to have all my numbers represented. So I have an x squared, an x, and a constant. If this started with x cubed, I'd say 1, and then what? If there was no x squared term, what would have to go right here? A 0. And then 5 and 6. Good question. Okay? Ready to go on? Okay. So whatever this number is, whatever this first number is, I just bring it down. Write it underneath the bar. Multiply that. What is it? Write it right there. And combine these two numbers. What do you get?
3.
5 and -2 is 3.
You multiply it.
Multiply these two numbers. -6. Write it right there.
And you combine it with 0, and you got 0 plus.
This very last one, I forgot to draw something for you.
Is that what you're dividing by?
What is that?
Is that what you're dividing by?
Oh, that's a remainder. This is the remainder box. Wherever the last number is, right underneath that is going to be the remainder box. Do you see your answer yet? Look what my answer is. Wherever my remainder box, the next number right beside it is the constant. The next number right beside that is the x term. My answer is x plus 3. Oh my gosh, that's the same thing I got over here.
That's easy.
Yep. All right, so can we do this one?
Yes.
Okay, so let's try it.
Wait.
So what goes on the outside? Equals 0, add 1, x equals 1.
Hold on.
I'm wowing as if I was a horse.
I said, ugh. I didn't say, whoa. I said,
Whatever I'm dividing by, I set it equal to 0. Just like I did up here. I set it equal to 0 and solved it, right? Now, some people say, well, it's just the opposite of that. Well, that works unless what you're dividing by is 2x plus 3. And then the opposite isn't just negative 3, is it? I have to set it equal to 0 and solve it. Okay? So set this equal to 0 and solve it. We're not going to be lazy here. What goes on the outside? 1. Now, what goes on the inside? 1, 5, 3, negative 4. What goes underneath the negative 4? Remainder box. Bring the first number down, straight down. 1. Multiply. Write it right here. 1. Add. 6. Multiply. Write it right here. 6. Add. Multiply. Write it right here. Add. Remainder. Constant. X term. X squared term. My answer is x squared plus 6x plus 9 plus 5 over what I was originally dividing by. Oh my gosh! So let's look at this one. You can be done in a second. Hold on. Let's look at this one. What goes on the outside? Uh-oh. You can't do that. So, to answer the question that I was just asked, and I was getting there, so good question. How do we know when we can decide if we can do it or not? How do we know when we can do synthetic division or not? What you got? So like what you're dividing by? If I'm dividing by just an x term.
I think if it has an exponent, it's going to be...
Yeah, we can't do it.
If it has an x, so
See how this is
so
squared?
it's like x cubed
Or
x,
cubed. Anything else besides just x. 2x plus 3 works because that's just an x. Right? 5x minus 9 would work. What else would work? 77x plus what? 4. Okay. 47x plus 6. Are you getting the idea? Any of these would work because I can immediately solve them for x. This one will not work because
it has an
it has an exponent that's not 1.
So, okay, if the x has an exponent, like, okay, there's no, there's like no number outside of it, so it's just the x with the exponent.
Can't do it.
No, I mean just, so like x squared. So it's just x squared minus 4. Does that work or not?
Nope, can't do it. If it's just this, can I do it? Because it has an exponent other than 1.
So it has to just be x. It can't be like x cubed.
Correct.
Okay.
Yes, sir.
Is there any way you can solve it? You put 3x and 5x over there and you can get it?
Nope.
Okay, so it's just...
Yep. Ma'am.
What if instead of like the subtraction sign, the addition sign, it was like a multiply of that?
Oh, you don't want to do that anyways.
What?
I'm lost.
That's something completely different, and that's not even on this topic.
Okay.
So we're definitely not going to talk about that right now. Okay?
So that's not going to be anywhere.
No.
Okay.
Cameron's just like,
You lying to me?
Questions about this?
Stupid?
Okay, so I'm going to set this, we're going to set this problem up. We're not going to do it. We're going to set it up. Is everybody understanding me?
Yes.
We're setting this problem up is all we're doing. We're not doing the problem. We're just setting it up. What goes on the outside?
X minus 3.
What goes on the outside?
3.
Oh!
Wait,
Oh!
can I do this one? Because it has an x to the third.
Yes, you're not dividing by that.
Oh, it's what I'm dividing by that matters. Okay, so what goes on the outside? 3. What goes on the inside? 4 and 5.
Yes. No, wait.
No.
Put
Oh,
0,
no?
it's got 2 terms.
Okay, so x to the third is there. X squared is not.
0's for x.
X is not.
Constant is.
And then the constant is. And then we got a remainder box under that. Don't forget that. Got to have all the terms represented.
So you bring the 4 down and then.
Yeah, we're not going to do it, remember? I mean, you can if you want. We can do this one if you want. I don't want to keep you from it. 4, 12, 12, 36, 36, 18, 108, 113.
Got it.
So somebody earlier was like, oh my gosh, that's such a big number. Really, relatively speaking, the distance from the Earth to the Moon is 113 a big number? No.
Well, what are we rolling with?
No.
Years?
Any questions?
No, man.
Got this? You have homework. Mark it, set, go.